The atom. The atom is the basic unit of matter and serves as our starting point for the study of chemistry. The atom is composed of the subatomic particle, proton, neutron, and electron. Scientists have studied atoms for hundreds of years and have developed a number of different models to describe them. As experimental technology has improved and new discoveries have been made, chemists currently use a quantum mechanical model for the atom. In this unit, we explore the structure and properties of atoms. We also study some of the basic tenets of quantum mechanics and how quantum mechanics describes atomic structure. Finally, we learn about the structure and organization of the periodic table of the elements. Atoms and elements. Let's begin by discussing the elements. You are probably familiar with many elements such as sodium, oxygen, and helium from everyday life. Elements correspond to the symbols you see listed on the periodic table. All atoms are made of subatomic particles, protons, neutrons, and electrons. Protons and neutrons exist in the nucleus or the high density center of the atom. Electrons exist as an electron cloud around the nucleus. Protons are positively charged, neutrons are not charged, electrons are negatively charged. Different elements are defined by the number of protons in the nucleus. For example, all hydrogen atoms have 1 proton in their nucleus. All helium atoms have 2 protons in their nucleus. The idea of atom, at one time a theory but now directly observable, is the basic concept that unites all aspects of chemistry. So this is where we begin. The idea of the atom and the element. What is the difference? The parallel concept of the element and the atom constitute the very foundation of the chemical science. Sulfur as element and sulfur as atom. An element is an actual physical substance that can't be broken down into a simpler form and is capable of an independent existence as observable matter. As such, the concept of the element, a macroscopic one that relates to the world that we can observe with our senses. An element is an actual, again, physical substance that can't be broken down into a simpler form and is capable of an independent existence as observable matter. As such, the concept of element is a macroscopic one that relates to the world that we can observe with our sense. The atom, on another side, is the microscopic realization of this concept. That is, it's the actual physical particle that is unique to each chemical element. Their very small size has long prevented atom from being observable by direct means, so their existence was not universally accepted until the late 19th century. The fact that we still hear mention of the atomic theory of matter should not simply imply that there is no any doubt about the existence of atoms. Few theories in the history of the science have been as thoroughly validated and are as well understood. Although the word atom usually refers to specific kind of particle, for example, our everyday use of element tend to be more general, referring not only to the substance composed of a particular type of atom. Bromine is one of the few elements that are liquid at room temperature, but also to atoms in a collective sense. Magnesium is one of the elements having 2 electrons in its outer shell. The underlying concept of atom as a basic building block of matter has been around for a long time. As early as 600 BC, the Indian philosopher Acharya Kanad wrote that every object of creation is made of atoms, which in turn connect with each other to form molecules. A couple of centuries later, in 460 before BC, the Greek philosopher Democritus reasoned that if you keep breaking a piece of matter into a smaller and smaller fragment, there will be some point at which the piece can't be made any smaller. He called the basic matter particles, in other words, atoms. But this was just philosophy. It would not become science until 1800, when John Dalton showed how the atomic concept followed naturally from the result of quantitative experiment based on weight measurement. The chemical element. The element is the fundamental unit of chemical identity. The philosopher element. The four elements of Western alchemy. This figure shows how the four elements were imagined to combine in various pairs to produce the quality of hot, cold, dry, and wet. The concept of element is an ancient one which developed in many different civilizations in an attempt to rationalize the variety of world and to understand the nature of change, such as that which occur when a piece of wood rots or is burned to produce charcoal or ash. Most well known to us are the four elements: earth, air, fire, and water, that were popularized by Greek philosophers, principally Empedocles and Aristotle, in period of 500-400 BC. To these, Vedic philosopher of India added space, while the ancient Chinese concept Wao Xing regarded earth, metal, wood, fire, water as fundamental. These basic elements were not generally considered to exist as the actual material we know as earth, water, but rather represented the principle or essences that these elements contributed to the various kinds of matter we encountered in the world. The chemist element Anthony Lavoisier, 1743 to 1904, eventually particle experience largely connected with the extraction of metal from ores and the beginning of scientific experimentation in the 18th century led to our modern concept of chemical element. An element is a substance, the simplest form to which any other chemical substance can be reduced through appropriate thermal or chemical treatment. Simplest in the context of experimentation at the time was defined in terms of weight. Cinnabar, mercury sulfide, can be broken down into two substances, mercury and sulfur, which themselves can't be reduced to any lighter form. The first textbook, Chemistry, Traité élémentaire de chimie, published by Anthony Lavoisier, the so-called father of chemistry, in 1789, contained the table of elements shown here. Although Lavoisier got many of these right, he did manage to include a few things that don't quite fit into our modern idea of what constitutes a chemical element. There are two such mistakes in top section of the table that you should be able to identify, even your French is less than tip-top. Can you find them? Try. 10 of the chemical elements have been known since ancient time. 5 more were discovered through the 17th century. Lavoisier, other misassignment of the element in the bottom section was not really his fault. Chalk, magnesia, baryte, and alumina and silica are highly stable oxygen-containing compounds. The high temperature required to break them down could not be achieved in Lavoisier time. Magnesia, after all, is water fire brick is made of. The proper classification of these substances was delayed until further experimentation revealed their true nature. Some frequently asked question about element. How many elements are there? 92 elements. have been found in nature. Around 25 more have been made artificially, but all of these decay into lighter elements, with some of them disappearing in minutes or even seconds. Where do the elements come from? The process by which elements, or more properly their nuclei, are formed is known as nucleosynthesis. The very first nuclei of the lightest element, hydrogen and helium, formed about 20 minutes after the Big Bang, 13.8 billion years ago. The next 23 elements, up through iron, are continuously being formed, mostly by nuclear fusion processes within a star, in which lighter nuclei combine into successively heavier elements. Elements heavier than iron can't be formed in this way and are produced only during the catastrophic collapse of massive stars' supernova explosion. How do the elements vary in abundance? Quite markedly and very differently in different bodies in the cosmos. Most of the atoms in the universe still consist of hydrogen, with helium being a distant second. On Earth, oxygen, silicon, aluminium are most abundant. These profiles serve as useful guide for conducting models for the formation of the Earth and other planetary bodies.